All right, let's jump right into the fascinating world of grade 8 coordinate geometry in today's explainer. We're going to look at how we can use numerical coordinates to unlock physical space. It's a concept that absolutely transforms how we understand distance and location on a grid.
Here's our roadmap for today. 1. Coordinate reasoning goals. 2. Modeling segment distance. 3. Finding the midpoint. 4. Verifying your results. 5. Geometry knowledge checks. And finally, 6. Recap and transfer.
Section 1. Coordinate reasoning goals.
So, before calculating anything, we really need to know exactly what we're aiming for. By the end of this explainer, you'll be able to use coordinate arithmetic to find the distance and midpoint of a segment and explain exactly how to check your result. Basically, you'll know how to use math on a coordinate plane to find lengths, locate the dead center of those lengths, and confidently verify your work every single time.
Section 2. Modeling segment distance.
Now that we have our target, let's model this with a clearly labeled practice segment. We've got endpoint A at 2, 4, and endpoint B at 8, 4. Remember, that first number, the x-coordinate, tells us our horizontal position, how far left or right we are. The second number, the y-coordinate, is our vertical position. Oh, and when we talk about distance here, we're measuring it in units, where a single unit is just one standard grid square on our plane.
Now check this out. Because the vertical positions of both endpoints are identical, they both have a y-coordinate of 4, we don't need some crazy complex diagonal distance formula. We can actually use a special horizontal case. Step 1 is just recognizing that this line is perfectly flat. Then for step 2, we find the distance simply by subtracting our x-coordinates and taking the absolute value. Why absolute value? Well, physical distance always has to be positive, right? You literally can't have a negative length. So we calculate the absolute value of 8 minus 2. And that gives us 6. Our total distance between endpoint A and endpoint B is exactly 6 units. It's just beautifully simple arithmetic that perfectly models the physical space between those 2 points.
Section 3. Finding the midpoint.
With our total distance established, let's figure out the exact center of our line segment. Finding the midpoint is really just about finding the balance point, or the mean. It's simply a matter of averaging your coordinates. Step 1, look at the horizontal spread. Add the x-coordinates together, so 2 plus 8 equals 10, and divide by 2, which gives us an x-coordinate of 5. For step 2, we do the exact same thing for the vertical. 4 plus 4 is 8, divided by 2 gives us 4.
So by systematically averaging those endpoints, we've successfully mapped our midpoint precisely at the coordinate pair 5, 4. No guessing, no eyeballing it. The math led us right to the exact center.
Section 4. Verifying your results.
In geometry, we never just guess. We really shouldn't trust a calculation without verifying it. If 5, 4 is truly the midpoint, it has to be exactly equidistant from both endpoints. Let's check it. The distance from endpoint A at 2, 4 to the midpoint at 5, 4 is the absolute value of 5 minus 2, which is 3 units. Now, the distance from the midpoint to endpoint B at 8, 4 is the absolute value of 8 minus 5, which is also 3 units. The distances match perfectly, so our midpoint is completely verified.
Section 5. Geometry knowledge checks.
Okay, let's actively test what we've just learned. Take a second to think about this first question. Which calculation correctly finds the midpoint and why? We just did the math, but what's the actual logic behind it?
Well, here's the reasoning. Averaging the coordinates is the correct calculation because finding the arithmetic mean logically identifies the exact physical center value between 2 endpoints. Think about it like finding the average of 2 test scores to find the middle ground of your performance. Averaging coordinates does the exact same thing, just on a number line or grid.
Ready for the second check? Flexibility is huge in math. So, how can a student check a distance or midpoint result using coordinates, a diagram, or a dynamic construction? What tools do you have in your toolbox to prove your answers?
You actually have 3 incredibly powerful methods here. First, like we just modeled, you can use coordinate arithmetic to ensure distances from the midpoint to both endpoints are equal. Second, you can use a diagram. Just plot the points on graph paper and physically count the unit squares. Simple, right?
And third, you can use dynamic construction. You can open up a program like GeoGebra, use their point and segment tools to plot your coordinates, and let the software digitally verify the exact measures for you.
Section 6. Recap and transfer.
Let's wrap up this explainer. We used coordinate arithmetic to calculate the distance of a horizontal segment by finding the absolute difference of its x-coordinates. Then we found its midpoint by averaging the x and y coordinates. And of course, we always verify our calculations by checking that the midpoint is equidistant to both endpoints. So, I want to leave you with this final transfer question to chew on. If you were given an unfamiliar coordinate diagram with a diagonal segment that is neither horizontal nor vertical, how would you adapt these exact arithmetic strategies to find its precise distance and midpoint?